Thank you, and thank you especially, Spela, for inviting me here. And yes, indeed, at Charles River, Finland, we are currently running an efficacy study using the CTNNB1 mice, and the study is at the moment at the very early phase, so we don't have any results to show you, but I will give you a brief overview of the study and describe some of the assays that we will be using, as well as give the essential timelines of the study. Yes, so the purpose of the study is namely to investigate whether treatment with the AAV5U or AAV9 could have an effect on the behavioral phenotype or the cognitive abilities of the CTNNB1 mice. And we are indeed using the very same mice that Adriano described in his talk. We did the breeding of the mice at our site and then did the genotyping at the very early age so that we would have a genotype info available once we started the treatment at the very early age. And then we did the ICV administrations, intracerebroventricular administrations with the AAVs at 4 weeks of age, and then we'll follow with the different behavioral tests, including motor behavioral tests and cognitive tests, as well as tests for anxiety at 3 different time points. And then, after those have been completed, then we will certainly collect all the tissues for ex vivo analysis. And here's just an overview of the study schedule. Before the treatment onset, we did open field test for the mice so that we can see possible very early phenotype on the general spontaneous activity of the mice. And then right after that, at 28 plus minus 3 days of age, we did the ICV administrations. And so those were actually completed right this week. So we are really in the early phase. And then at 12, 20, and 30 weeks of age, we will be doing the behavioral test. For the motor behavior, we will be doing the rotarod and kinematic gait analysis at each of these time points. And then for anxiety, we will do marble bearing test similarly at all of these time points. And then for the cognition, we will have radial water maze at 12 and 20 weeks, then contextual field conditioning at 20 weeks, and then Y maze at 20 and 30 weeks of age. And here are the different treatment groups. One group of wild-type mice as well as one group of heterozygote CTNNB1 mice were treated with the AAV GFP, and these groups are used as controls. And then we had 3 groups of heterozygote mice treated with the AAV5U, low, mid, and high dose. And similarly, 3 groups of heterozygote mice treated with the AAV-INS, similarly at low, mid, and high dose. And in the heterozygote groups, we had N of 16, and in the wild types, N of 10. And actually, since our discussions with Spela earlier this week, we increased the number of the wild types to 14 to have a little bit more power for the analysis. Yes, so we received the vectors from Children's Medical Research Institute Australia as readily injectable solutions. Thanks for Andrea and your colleagues for these. And then we infused the mice with the volume of 5 microliters in the ICV space. And here, this red cross refers to the target coordinate we had for the infusions. And the infusions were performed under anesthesia. Yes. And always before we do such infusions in a study, we like to do also pilot infusions so that we know that we target really the coordinates we want to have. Especially if you're working with young mice, like in this case, and some new transgenic or genetically modified mice, this is something that you like to do. And for that, we injected a very small volume of Evans blue dye in these coordinates in the ventricle, and then sliced the brains of the mice right after that. And we used namely the surplus mice from the breeding, both wild type and heterozygote mice. And as you can see in the image here, this is an example from a heterozygote mice. So the infusion spread, or the dye spread very nicely throughout the ventricular space. So we were confident that we can continue using these, proceed with using these plant coordinates also in the actual study. Adrian already explained pretty well the rotarod, so no need to go through that. But anyway, this is one of the motor tests we will be doing, and we will be running first at each time point trial run with the slow, stable speed, and followed by 3 accelerating speed from 0 to 40 RPM within 6 minutes. And namely, the latency to fall from the rod will be used as a measure. And then for the anxiety, we will be using marble bearing. Marble bearing has been commonly used for studying anxiety and obsessive compulsive behavior in mice, and it is based on the observation that the mice prefer to bury all harmless and harmful objects in the bedding, and this behavior has been indicated or implicated in anxiety of the mice. And in this test, this is how it looks before the test actually. So we place the marbles in the cage and then place the mouse there for 30 minutes, and then after that we look at the outcome, which may look something like this. The mouse a healthy mouse may often bury majority of the marbles. And here just an example data of another strain, BTBR mice, which has been used as a model for anxiety. You can see that the BTBR mice bury more marbles, even more marbles than the healthy controls. So might be considered potentially as indicative of increased anxiety in these mice. And by the way, in contrast, if you give, for example, selective serotonin reuptake inhibitors or benzodiazepines for the mice, then the number of buried marbles decreases, indicative of perhaps decreased anxiety levels. And then when you want to have a comprehensive view of the mouse motor capabilities, then we do the kinematic gait analysis. So gait is the most common, can we say, most common way of movement for mice, and there are different forms of gait as well, starting from slow walking to more faster gallop and trot-like gait. And what we are really doing here, we can say that the analysis is a systematic and quantitative study for the mouse locomotion, and in practice what we do, we measure the different movement of the different joints and bones, and then also the interactions of those. And we use a marker-based motion capture. First we track the trajectories while the mouse is moving, and then from those, using some mathematical equations, we will be able to create this kind of gait model for the animal. And with this we will get a a large number of different individual parameters or variables describing the different features of the gate. And here's just a short video describing the setup of the test. So we have this is slow motion by the way, but we have a camera, high-speed camera under the mouse, and then we have mirrors at both sides of the corridor while the mouse is allowed to move freely, spontaneously there, and then we will get the view from both sides and bottom at the same time. So we will get not 3D image, but anyway image and video from 3 different angles at the same time. And once we then have done the tracking of the different points we measure, then we will be able to create this kind of reconstruction of the movement, which we will then again we will not use these kind of representative videos for the analysis. Instead, we use the values and which we get from the mathematical equations. But this is just an example from another mouse model of Huntington's disease, by the way, also affected by one gene mutation only. So in the top panel you can see a wild-type mouse running or walking very smoothly. However, you can clearly see that the R62 mouse has various difficulties while moving there. I'm not going to details of the data or the data analysis, but in principle, as said, we will get the information of these numerous individual variables, which are, of course, as themselves are valuable as is, but in order to get a clear and comprehensive view of data with such multivariate data, we do principal component analysis, with which we will be able to get a smaller number of sensitive and uncorrelated parameters. And in addition to that, we will be able to see possible correlations between the individual parameters. And I think the strength of this assay is that this, according to our experience, this is more sensitive to capture the phenotype of the mouse compared to more conventional motor assays. And in addition to that, it has been shown to be sensitive to capture possible treatment effects. Then for the cognitive assays, we will have radial water maze. This is an modified version of the Morris water maze, but the principle in both is the same, that we have a pool of water, and then at the one specific point of the place of the tank, there is a hidden platform under the surface, and the mouse is expected to find the platform over the trials. And here we will use 15 trials a day for 2 days, and the platform remains in the same position each time. And again, a very short video of an example mouse doing the task, trying to find it, and found it pretty quickly actually. And then another cognitive test, also assessing say spatial reference memory, could be considered to be and expected to be dependent largely on hippocampal functions among the other related brain areas, which broadly speaking could be perhaps compared to the declarative memory in humans. But here we have a Y-shaped maze with 3 arms, and we will have 2 trials. On the first trial, one of the arms is blocked, so the mouse is given chance to explore the 2 of the arms, and then 1 hour after that this block is removed, so the mouse is allowed to explore all 3 arms. And in the second trial, one could expect that the mouse would explore this arm that was blocked on the first trial. So very simple principle. Just again an example video, so the mouse is exploring the arm pretty actively. And for the memory index, we then used from the second trial the the time the mouse spent in the novel arm and the number of entries to the novel arm. And then we plan to do also the contextual field conditioning at 20 weeks, and Adriano explained this as well. So, but anyway, as he said, so we will place the mouse in a novel environment, a test chamber, and in which it will get a few mild food shocks, and then once we place the mouse again on the following day on the same chamber, if we expect that the mouse remembers, it should show freezing there, so the time spent freezing will be measured, and everything else, regardless the movement related to breathing, is not allowed if we score it freezing. And just again a short video. So mouse is really immobile there when it shows a good freezing behavior. And then after all of these have been completed, then we will have the endpoint tissue sample collection, and we have preliminary discussed some of the possible ex vivo analysis, for example clinical chemistry, complete blood count, and possibly immunohistochemistry among others. But anyway, there will be fresh frozen tissues and fixed tissues. The details of these still to be decided. By the way, we will still discussing whether we continue until the 20 or 30 weeks of age. So we may decide that together with the foundation based on the early results from the behavioral tests. And the timelines, as I mentioned, this week we completed the ICV administrations, and everything. Sorry, here. And everything appeared to be well. The mice recovered very well, and yes, those went well. And then the next essential time point is by the end of May, when we will have the completed the first 12-week time point measurements, and we'll have the results in hand pretty soon after that. And then by the late July, we will have the next 20-week time point completed, and if we agree to continue until 30 weeks, that will be completed by the end of September. I then want to thank my colleagues already have taken part in these projects in cooperation, especially Markku for working with the practicalities in the in vivo lab, and Leena for being lead in the genotyping, Henni, Riikka and Karoliina. Thank you.